Hey, how you doing? My name's Sean, and I put solar on RVs, and my son here, Levi, he helps out quite a bit too. In this episode, we are putting together a nice solar system on this Grand Design Momentum. I think that's what it says. That is true. The reason why I can't tell all the time is we do this a lot. So if you want to see how a full Victron solar system gets put into this particular fifth wheel, stick around. We got a lot of things. It's a 24-volt system. 4 Epoch 24-volt batteries, 2 multi-plus inverters, 2 solar chargers, probably somewhere between 10 and 12 panels. That would be 200 or 2,500 or up to 3,000 watts of solar. We'll see what happens. Well, without further ado, I'm going to get at it and show you what I've been working on. Levi's going to continue prepping panels. He's usually the solar guy on this. I'm hanging it up. I'm not putting solar on the roof anymore. It's all you now.
Okay.
Yeah, no, I still
do it.
Yeah, you're going to do a good job. All right. So before we dive into this one, let's dive into it. How about that? I want to go over what we think we're going to be able to put in here and where and how we're going to do it. I've already started some of the work, and that's kind of why I thought, hey, I should start sharing some of this stuff. So let's start in the front bay here. A lot of times we put almost everything here, but in this particular case, I don't think we're gonna be able to do that because this is a 2 inverter system. I think we're gonna put both inverters here, and the reason why is they wanna run air conditioning, so we gotta be able to exhaust the heat out of here. So I think it makes sense to do that that way. So we're gonna do both of the inverters there. We're gonna take out one of these batteries for sure. And again, this is a 24-volt system. So then we're gonna run probably the power cables up through here, both the AC and the DC. Transfer switches right here. That'll work out pretty good. And the main box is over there. The customer actually did a little bit of remodeling here and definitely made a lot more space. Typically there's just a board that goes from there, pure diagonal all the way over to there, and you give up a lot of space. So he kind of squared this off here. And I think what we're gonna do is put our batteries here. We're gonna do 4 of those batteries. And then actually, the only thing I think that makes sense, and we haven't really done this too often, I think we're gonna go up. We're gonna try and mount, I think, everything on the ceiling. And to do that, I think the way it makes sense to do that is to actually design a board and then put the board up on the ceiling. But that's the only room I'm seeing left. We could do the wall here, but I don't think we're gonna have much room on the back wall or this wall because of the way the batteries are, but we'll see. I could maybe step the batteries up here a little bit, but we'll see. This is one of those things where we try and investigate things as much as possible, but then I'll tag in the customer, we'll talk about this, and we'll figure out the best solution, because ultimately we don't have to live with this system at the end of the day. You guys do, or customer, whoever. So I really try to bend in that way. What's going to be most useful for you? Does this customer want more storage space, or would they like a little bit better accessibility? That's going to be the trade-off here. So what I've been working on right now is running the HDMI cable for the Cerbo display. Many of you like those nice touchscreen displays, and a lot of times we put it here, but we're not going to go there because this is a pocket door, and the pocket door is not, the cavity is not big enough. The door actually pretty much goes right here. And unlike the in-command system here, we're not going to be able to put it on this wall because it's an external wall and it's all insulated. The only spot left that I see that would work good is right here. So to do that, what I did was I popped down this false bottom plate here. There's a little, it's got a couple of switches and a USB power thing. And we're going to probably be using some of those wires here later. But what I did, we'll see if we can take a peek there. You can maybe see I got a hole in there, and I was able to run my camera up through there. Hey, how you doing? Run it up through there. And actually what I did was I had these long needle nose pliers, and I had them in the hole, and I just set them like that, and then I was able to put the camera right in it like that. Or actually it was the other way around, so I could pull it out. Because I was trying to run the camera down, but it was too hard because it's got to make it pretty much a tight 90 and go down, and that just wasn't working. To drill the hole, I had to use one of these kind of, not quite a 40 or a 90 degree angle bit, but like a, we'll call it an 80 degree bend. And then this kind of hole saw, that worked out pretty well. And as far as I'm aware, I didn't cut through any wires. Fingers crossed, wires crossed. All right, so next step is to tape up the end here. Actually, it's going to be this end, because this is going to go to the Cerbo, and then the display is going to go right here. So I need to turn off the camera so this LED doesn't keep getting hotter. We'll pull that cord back through, and then we can check that off the list. All right, I've spent quite a while fishing this line around, and obviously you can tell I got the screen mounted, but I'm going to show you what else we had to do to get this going in here. Had to do some like double top secret chiseling and multi-tooling to get the cable through there. You can kind of see hopefully what we had to do, and then this guy should go back up there. And what I was trying to do was avoid any penetration beyond these supports right here, so we can put a piece of wood right up against here or something to just kind of hide all that. So be looking for how that turns out in the future. That's going to probably involve some staining and actual craftsmanship, so we'll see about that. Oh, I also wanted to mention how we've been doing this more and more for the powering this screen remotely. So use like a little 12 volt, actually this is a 1224 input, and it spits out one USB plug here. Then we like to tape them together, and of course I like to tape this together too. And what I'll end up doing is shoving all of this in this cavity here. So yeah, I think there's plenty of room. We'll find out. And yeah, and then this can go back up there. Oh, and then connect it all with Wagos. Still like really doing that. So there was 12 volt power here. Why not? It'll work. All right, up here on the roof, and I'm going to be trying to pull the wire up. So we'll see how that goes. Before we can get the solar up here, obviously I got to get the second run of solar up here. We already got one pre-wire, but we need a second one, so we're going to be using the satellite chaseway. Are you ready, JD, to feed me?
Captain.
All right. Now I gotta find the wire again. Hold on. We got it ran up here with the pull string here, and I'm doing the owner a favor, and I'm putting my own pull string in here. I'm going to pull this green string back down, so that way if they ever want to run something extra, like a Starlink or something else, they can do that easy enough. It's just something I like to try and do whenever possible. Keep things reusable. Thank you, JD.
You're welcome.
JD's going to get back to work.
Day.
What?
Have a great day.
I will.
Okay.
All right, so we're going to get this terminated up here. We got a port here. We'll cover this up, and we'll be on our way. Hopefully getting solar up on this thing. All right, we got this taken care of. It's getting hot out here, so I better refill my water, but we're ready to start getting panels up here and start laying those out. I'll have Levi get some ends on there. But like I said, I think we can get 12 panels up here. We were very confident at 10, but we made a plan for 12, and I think we're gonna execute on it, so let's hope for the best there. All right, if anybody's curious how 3,000 watts of solar gets on a Grand Design Momentum, this is how we're doing it. And there's Mr. Solar himself, Levi. He's going to be wiring this up here in a minute. I stepped in that, but luckily Dicor starts setting up and skinning over pretty quick, so no harm, no foul there. But when we're doing these 250s here, it gets real tight. This is pretty much our walkway. Now, one of the things I'm considering and thinking about when I'm laying out these panels is shadowing. So shadowing and walkways and serviceability of your air conditioners. And I think we've preserved all of it. We can get pretty much everywhere we need to go. As you can see, you can get a foot right through there. And I'm wearing Crocs because those are safety equipment up here on the roof because they don't damage the roof at all. And they're darn comfortable. But yeah, we can get everywhere. You can get around an air conditioner, put a soft start in, which is something we're going to have to do. Actually, I should probably do that here pretty quick before the boy gets too much further down on here. But as you can see, we can get around here just fine. Yep. If we did a rack system and we went over these vents, you could probably get at least 2 more panels up here for sure. Or you move those here, these 2 that are sideways, you straighten those out. So Levi was wondering, hey, how are we going to wire these up? And that's a question a lot of people have. So what I'm thinking we're going to do, again, I'm thinking about shadowing. I think we're going to do these two in series, and that's what our goal is, to make series pairs. These are the 24 volt panels, and we are doing a 24 volt system, but you can use 24 volt panels on a 12 volt system. I really recommend always doing 24 volt panels because they run at 45 volts VOC. That means we get our volts up to about 90 to 80 when we're working. And that means you can run a lot of power through 10 gauge wires. So what we're going to be doing is doing 1, 2 in series, and then I think 3, 4 in series. And then, or wait a minute, let's think this through. What if we did 1, 2 in series? Yeah, 1, 2 in series, 3, 4 in series, 5, 6 in series. What do you think?
I agree.
Okay. So the reason why I'm thinking about that is if we get shadow on this side, that's going to take out this panel and his buddy over there, that panel. And then if we get, well, this should never be shaded. And then these two would get shaded if the sun was coming this way. So they kind of take each other out, and that's good. We want to eliminate as much partial shade issues as possible. And as far as the other solar port goes, it's right under here. So Levi's gonna have to move this panel and then get a pigtail going. And then I think here, we just keep it real simple. We'll do 1, 2 in series, 3, 4 in series, 5, 6 in series. Does that make sense? And then we parallel those all together. And usually we just use the branch connectors. So we would make a group of 4 there, parallel those together, and then have 2 wires coming down, parallel again here, and then 2 wires running into the port. Leave a comment down below if you got any questions on what we're doing, or also if you want, what is he doing back there? He's vibing. If you want us to do something like this to your RV, now's a great time to visit our website, sotasolar.com. You can browse it. We do sell equipment. We sell packages. Let us know. We can put something together for you. I'm trying to think what else. Oh, you can subscribe too. That costs you $0. And I guarantee you, if you don't like it, you can, he's a goof. I will give you your money back. Guaranteed. Let's check in with JD here. What do you got going on?
All right. I am making connections in the transfer switch right here. So it's really nice. On the other side of the wall is where we're going to be throwing the inverters. This line right here already runs up to the breaker box inside the rig. Now I'm going to do this one. We're going from the output of the transfer switch, which is going to go to the input of our dual multi-plus configuration. So pulling this line out right here as we're doing it. So this was the run going from the transfer switch up to the breaker box. So this line right here ain't needed no more. No more. All right. So
are you pulling that out, or are we just going to like tape it up and let people know, hey, don't use this anymore?
I think I'm going to pull it out because it's only like 5 feet long.
All right.
It's pretty straightforward.
All right, JD. Well, you look comfortable, so I'll.
Yes, this is a great fun. Great fun. Could you give me a pillow?
I'll leave you to. I can get you a pad or something to put your knees on. Or...
No, it's okay. It's my ankle that's hurting.
Okay. Hashtag life over 40, right? We're both there.
What? No, I'm getting close to
really?
30.
Close to 40? That's what I say.
Close to 30.
What?
On the other end. Like,
Are you not 40 yet?
Still close to 30. Well, yeah, it might be. Or past that.
Okay. All right, we're doing a couple other things on the roof here, and Levi just asked me a great question, which is, so he's wiring up the port, and watch your feet there. He's wiring up this port, and it's a real common mistake because these have plus and minus printed on them. There's the plus. But when you're wiring up the port, right, it's backwards. That's what he was asking me about. And he's going to go ahead and crimp it there. I think you want that's the opposite way. Or, oh no, you were doing it right. Never mind. You know what? I'm going to quit telling him what to do. He knows what to do.
Oh, that's okay.
But that's the key there. Just make sure you get your, you put your ends at your port backwards. If you want to think about polarity, you want to think about from the panel is positive, negative. When you come from the ports and your chargers and stuff, it's backwards. It's easy. All right, the other thing I was going to mention is got the cover on the air conditioner off because we don't just do solar here at the Sota Solar. I often tell people solar is about 20% of what we do. The rest is batteries, running wire, inverters, all that stuff. But we're going to be installing 3 of these Spartan starts. They're very similar to like a soft start or the micro easy start. And what I like about these is, one, they do work good. They're a little more affordable, but they're super simple to wire up. Pretty much it's just on the compressor side. You don't really have to mess with much else. You just, yeah, hook it up and away you go. The diagram is pretty much right here. Hey, check out this hat I got for Father's Day. It's got solar panels on it. Keeps the sun off me, and it keeps me cool. It's got these solar powered fans. I love it. Let me show you what we've been working on here and why I've needed this hat. All right, we have solar up here and it's wired up. Got a little wire tidying to do yet. Levi did all the wiring and we checked the voltages. They look good down below. I always recommend when you're doing these together, check your voltages as you go. That will help identify. Let's start over. All right, we've been hard at work getting solar up here and installed. Well, not installed, but we did get it wired up. Levi did all the wiring on this, and I think he did a pretty darn good job. We've got some tidying to do yet, but we went through and we checked all the voltages. If you're doing this on your own RV, I would really recommend you check your voltages as you go. So when you put like these two together, you're gonna get 90 some volts. Put those two together, you're gonna get 90, and you wanna have 90 coming out. If you don't, that means you got a panel wired backwards, and you wanna figure that out as soon as possible. These panels can sustain some reverse polarity for some time, but you wanna identify those problems as soon as possible. All right, I've got one more air conditioner to put a soft start in, and then I'm done here for the day. Well, here we are in the shop this morning, working on getting our batteries and boards put together. JD's working on the inverter board right now and having himself some breakfast. So
putting wires in when you're eating a donut.
it is. That's the sacrifices we make for our customers and for you.
I'll set the donut down.
There you go, safety first.
There we go.
Let's start with what JD's working on here. We're doing some advanced configurations, I would say, with our wiring, in part because the inverters are far away from our batteries, and we can't think of a reason not to do it so far. We're going to be running a single 4/0 cable to here, and we're going to double land on that lug, and we're going to polish them up real good so we get a good connection. And then we're going to fuse those individually with 200 amp fuses. And then those are going to go to 2/0 cable running into each multi-plus, rather than running 4 conductors of 2/0 to the inverters from the batteries. Mm-hmm. And hopefully that works out good. I think it will.
Makes it a lot simpler.
Hopefully. Mm-hmm. So, and then we'll be doing the paralleling of everything in here. And just because we're really tight on space here, I think we're going to go with our trusty splices on those, and we'll wrap those in heat shrink. We can get 2 of the 6 gauge in one side and then 1 6 gauge obviously on the other side, and we've done that plenty of times without really any issues. Again, this is going to be a parallel setup, so no auto transformer. That's one of the advantages of parallel, is you don't need an auto transformer because they're in balance by default, I guess.
Yeah, they're both outputting to the same loads, so
yep,
they're splitting it. It's balanced.
Yep. The only downside with that is your minimum AC input current limit is doubled. So if it's normally 9.2, it's now 18.4 or something like that. So it does mean it's a little harder to connect to the tiniest of generators, but if at least you got like a Honda 3200 or something, you'll be just fine. Then over here, this is what I'm working on. This is how I think the batteries are going to go together. And rather than doing all this in the compartment, we're going to basically, what I like to do is set up a model of it here. And this is what I'm thinking. Doing all the battery programming, we are actually going to hook these together and connect them up to the Cerbo GX system, and we'll model all that out here. But basically, I think we're going to mount them this way in the compartment. So if we're in the door, this is what we're seeing right here off to our left. And we'll put all the equipment right here. I know we were thinking about it on the ceiling, but this just, I feel like, makes a lot more sense. We'll run our batteries, together here into a Lynx distributor. We could use a power in, but why not? We can add a little bit more lights if we do a Lynx power in and we get fusing on there. Now, there are fusing in these, but I would rather not rely on the fusing here for my primary because it is a pain in the butt to change the fuses in these. So I'd rather have the fuses on those, and we'll do the 200 amp fuses in there. So that's all I've got for now. Stick around and we'll see where this goes. We are still working on this sub-assembly here, but you can see how it's kind of coming together. We got the Lynx power in, or Lynx distributor we're using as a power in because we like its fusing capabilities. We're gonna put the big die-wheel breaker right here. I'm about ready to make up those cables and mount that. And then over here, we'll have the rest of the equipment. Got the Cerbo, 2 solar chargers, solar breakers, and the Lynx distributor, all somewhat easily accessible. And then the inverter batteries, or the inverter power cables, will come out of here, up through here, up through here, up there, across the ceiling, and into the front bay, which is right here in 3D space. That's the way you'd think about that. So we're just trying to do as much of the work we can in here and then bring it out there. And Bear's keeping an eye on us here, making sure we're on task. I got the batteries finally figured out, finally programmed. We've got all 4 batteries online, 920 amp hours, all talking, doing all the Victron stuff. So hopefully that works out okay. We have played around with using Victron communications in combination with shunts and the different kinds of things. In this one, we're going to go 100% leaning on the communications here for the battery monitoring, kind of simplifying this end a little bit. But next step is going to be transferring all this into the 5th wheel, and then we'll meet you there. All right, we're going to look over JD's shoulder here.
Yeah.
He's getting...
I put on deodorant today, too.
Oh, thank you.
Yeah, you're welcome.
Like, comment, subscribe if you like that. So here's what he's got put together here. The batteries are all tucked away back there. Yeah, maybe we'll try and get, I don't know if you can see them back there, but they are there. All 4 of them.
I don't know if you really could. With the endoscope, you can see.
Yeah, probably.
They are back there.
I was working on something else while he got that taken care of. Nice job.
Yep, got that boarded. Actually, it wasn't too bad once everything had prepped it. Back behind here, something that was nice. So we did the like a bracket like this using angled aluminum, but secured it to this top back there first and measured everything, so that way we could just slap the board up to that and then screw through the board into the angle aluminum. I think that made it a lot easier to get this lined up.
Love it. Love it when a plan comes together.
Oh, I know. It's
all right.
Cookie cutter.
It's coming together here. Last day. We are we're actually officially on. We just threw the main switch, getting about 1,000 watts per array right now in this partly sunny, partly cloudy, whatever we're going to call it, weather. It's pretty direct sun right now, I would say, based on the shadows. But yeah, it's coming together, and JD's just putting together the 12-volt battery in here. And we currently have those inverters off, but they will be on. And we're going to try the AutoGen start here, too. We ended up going with the, sorry, I'm over JD's shoulder, the time delay relay option. So we're going to try that. And yeah. And of course, we got the bear here keeping an eye on us. What's up, bud? All right, we got both of the multi-pluses here programmed. JD wired in a thermostat here, and it's blowing out the hot air that these are creating. They're actually running 2 air conditioners right now, 100% from solar. How crazy is that? Well, that's the goal of a system this big. And then here, I'm trying to get the AutoGen shutoff to work. Actually, the start works just fine. It's the shutoff side that I want to work correctly. So I'm still playing around with that. What I'm trying to do is the normal settings that we can find on the internet are having the relay be active all the time. So what it ends up doing is priming the generator all the time, which we don't want to do. This is a gas one. We don't want to be just wasting gas. So playing around with a couple of different settings there, see what we can figure out. All right, I think we got our AutoGen start stuff sorted out. Dave, can you go start it? Now, it's not actually going to start the generator, but this is the start relay here, and that should light. And the blinking means it's simulating the start button push. So that's how long it would hold the start down just to make sure it starts. And then Dave, can you turn it, do manual off? And Dave's going to turn it off, and there it goes, and that's the stop signal. Feel free to pause the video. I'm going to show you the settings we got here and how we got it all wired. We use these terminal blocks for positives, negatives, all that kind of stuff. JD figured all that out. All right, and then I'm going to plug the generator back in, and then we'll simulate actually starting the generator so you can believe us that it works. All right, start it. Go. Well, it's Friday evening, and we've pretty much wrapped everything up. Why don't you take a look, and I'm going to bust out the thermal imaging camera here, and let's see how things are doing. It's actually been charging most of the afternoon. We're at about 97%. All right, now this has been running with the door closed for quite some time. Here's how it all looks again. Got some covers all put on there. It looks real good. Let's take a look at our thermal camera here. And you can definitely see the exhaust port there is doing its job. I know I'm doing kind of filming a camera with a camera, so that's a little weird. But yeah. You can tell those inverters are definitely getting warm, aren't they? 123 degrees, but let's see what the temperature everything else is. I think this fan here is doing its job, putting out 99, 95 degree air. I think that's about as good as we're going to get, and this has been running again for probably about 4 or 5 hours now. Let's go check the other bay. Now this, I'm really interested to see how these wires are going to work there. Those feeder wires for the Lynx power in, and of course our shutoff switch and all that. Of course, I think this came out just absolutely beautiful here. Really like that, but let's take a look here. To be expected, definitely generating some heat in here. Looks like we're at 110 on the switch, and that's actually the hottest part, which isn't too bad considering the wires are 94 or something. Switches are always the hot spot on these. Let's see how the rest of this is doing here. Yeah, those getting a little bit warm too. 109, 110. This is 4-aught cabling, even though this is a 24-volt system. But that's the way connections and fusings generally go. Is the fuses generate heat as a function of how they work. And yeah, we got the cabling up across there. That's getting a little bit warm too. That's just that 4-aught cabling. It's just getting hot because we're pushing about 150, 160 amps through it for 4 or 5 hours. But nothing crazy. That's just fine to me. I think this came out real good. And then inside here, I don't know, you want to see what things look like inside? Oh, yeah, the screen does get a little bit warm. Hey, oh, the screen's at 104 too. But yeah, I don't know. Can we learn anything in here? Yeah. Slides and air and fridges make a lot of heat. How about that? What, do we see anything else in here? No, not a whole lot. All right. But yeah, we're still charging. We're at 98%. Now we're down to 105 amps into the batteries. So we'll keep going. Get her charged up for pickup tomorrow. And don't forget, of course, the solar up here. Again, 3,000 watts. Look at this. Levi did a great job, I have to say. He's gotten a lot better. Actually, I didn't have to come back and tidy up the wires or anything. I think he did a pretty good job up here. Great job. So from all of us here at Soda Solar, myself, Sean, Levi, my son, JD, back from Quartzsite, and Dave, he's working on this box truck here. We're going to show you a little bit more about what we're doing with that later. Again, subscribe if you want to see the crazy that we're doing. Yeah, we loved having you along on this episode. So check us out at sotasolar.com, S-O-T-A-S-O-L-A-R, spelled like that, with a R at the end and a little sunshine emoji, or you can replace it with an O if you're crazy like that. So, all right. If you're hanging around just seeing when is this video gonna end, I don't know, maybe I'll stretch it out and I'll do something really crazy. Hopefully not fall off. I'm about ready to get off the roof. All right, you guys have been great. Thank you. We'll see you next time. Bye. All right, here's a little bonus footage for the fans out there. I just noticed this. Check this out. I think we've got Canadian wildfire smoke on the way. Look at kind of just how hazy it looks out there. And I'm gonna zoom way in. See? Normally, we don't have mountains or anything out there. That definitely looks like there's some smoke in the air. Everything as I look around is looking hazy and it's smelling a little smoky. And the bonus tip for those of you that are still watching, don't tell anybody, but the smoke in the atmosphere, that definitely knocks your solar down. I'd say anywhere from 10 to 20%. So again, that's the reason why you want 3,000 watts on here. You can never have too much. I don't know what else to tell you.